the Linaro Connect Budapest 2017. And so what's the latest?
Well, hello, Charbak. It's good to see you again. When did we do our first interview? I think it was kind of 5 years ago.
Yeah, nearly 5 years ago, I think, in Hong Kong.
Yeah, wow, it's been a bit of a ride. What's new here? Lots of new things. On the Linux kernel front, basically all of the teams that are working around the kernel, which is the embedded group, the networking group, the enterprise group, the home group, there's a tremendous amount of alignment between those guys and the way that patches are put together and flow upstream. As you know, our kernel team has been working for 5-6 years. It was one of the first teams in Linaro, and it's really helped organize the code so that it is upstream. And one of the things we've been doing this week is work around aligning with AOSP and Android and that kernel and features there, so that basically you've got a whole range of technologies that flow into the kernel from the ARM side that then flow out again to products. So we're kind of trying to make the link between what happens in the kernel and what's picked up by the distributions and how that all fits together.
If I remember correctly, 4 or 5 years ago when you did the interview, you talked about you'd like to see an Android kernel and the Linux kernel.
Yeah, and
there's
well, not necessarily merge, but there to be a comfortable engineering relationship between the guys doing Android and the guys doing, quotes, Linux. At that time, a lot of Linux folks were pretty biased about Android as a silly thing, as not a real open source thing. But actually it is, and there's a lot of goodness flows in both directions, and it really works better. 5 years ago, things were pretty disorganized and ad hoc, and one company would do it well, another would do it badly. And in the time that we've been working on this, and all our members, this isn't just, Linaro is a collection of people. We've really got ourselves organised. But that's not the only area. The tool chain's the same. Working on technologies such as containers, it's much more organised. And the members are better, really, at working outside their firewall. So as an example, ARM has put most of its engineers who are working to support the architecture are outside the ARM firewall and inside Linaro, and the member engineers are with them. So if you walk around, you see these groups of engineers doing the right thing, and part of this is just effort over time is going to work that way.
Is it so? There was this where Linaro has become the #1 contributor.
Yeah, I was really proud of that because
#1 in front of Intel and for everybody else.
Yeah, it was a bit of a blip because there was a bunch of work that had been pending around things, but it shows what those guys are doing. They're really shoveling code. No, well, that sounds bad. It's really well structured, well organized code. There are guys who care what the kernel looks like and the structure of the code, and they're doing a good job.
So some of these guys around here sitting around doing all kinds of meetings, hacking and all that stuff.
That's actually work. It may look like guys sitting around gassing, but actually these are the best in their field.
And they're getting
and they're
Linux
probably
kernel.
talking about the next, the closed window for the next release candidate, or the piece of code they're doing. So this is why Connect is really good, because it's bunches of people doing what people do, which is talk and agree and do the face-to-face thing.
Linaro is a very engineering
yes,
organization.
very focused on engineering. Yeah,
like 99%.
99.9%. They're all geeks like me. There's an element of business to it because obviously, we need members to fund this work, and it's quite a difficult sell. It's kind of a sell based on belief, right? But
everybody works at home, right?
No, think about it. It's like I said 5 years ago that joining Linaro was like joining a gym, right? There's no point joining the gym unless you use the machinery, you join in and you listen to the trainer, right? So Linaro is you pay us money and we pay for engineers with it, and you give us some of your engineers and we all work together.
So it's twice a year?
We meet twice a year, yeah. There's 2 of these connects for about a week, and they're really intense and hard work.
Monday to Friday?
Monday to Friday. Well, yeah, but I arrived like last Friday, and we had meetings over the weekend. But this is like Linaro has an office for the week. And here, this is the second time we've been in Budapest. We were here 6 years ago, and it wasn't called a Connect. And this is a beautiful hotel. I hope you videoed some other pieces.
This
but
is
it's
the Grand Budapest Hotel,
yeah,
right?
exactly. Yeah, it's an absolutely beautiful place.
And so it's easy. No, it's not easy, but people fly in from all over the world.
Yeah, it's very easy for me. It's like a 2.5-hour flight from Heathrow. It's less easy from other places, but
They come from
coming
China,
back to Europe,
they
we
come from
mostly
Korea.
they come from our members, engineers. It's like 30 countries. I mean, they're coming from everywhere. Everybody comes here. It's like a week of. It's a mixture of hacking, of meetings. There's 28 hours of committee meetings, right? I don't go to all of them. I can't physically do it. I can't be in two places at once.
So am I correct in thinking that, like you were saying 5 years ago, that you want Android and the Linux kernel to interoperate?
To align, yeah.
Yeah. Is it true that Linaro contributed a lot in terms of how awesome Android is on ARM?
Yeah,
And
it was one of the contributors.
All the work you did is in all of Android.
Oh yeah,
phones,
yeah,
all over the world.
absolutely, yeah, absolutely. So when it's great because I can explain my job easily. I just hold up my phone and I say, I'm working with a bunch of people who help make this happen.
You make it 33% faster.
Whatever.
Or
Yeah.
something.
Well, I tell you, I've got this. This is a bit of an advert, but this is a Pixel phone, and it is, awesome battery on it. I mean,
So-
it's just. I won't show you my phone.
Yeah, but how
But
many
it-
percent of this is Linaro's? Thanks to Linaro. No, I'm joking.
I could.
but
No,
you
to be honest,
say,
I
but
couldn't.
there is
I couldn't.
something.
Yeah. There's a bunch of stuff.
Like
But-
all the optimizations, every
Well,
different
one
corner
of the
ARM
things this has
architecture.
got is the power management in it. So the adaptive power management that schedules work appropriately over many cores, big and little. So all of that stuff that was developed again, as I say, outside of ARM's firewall, with some great kernel guys and the rest of it. That's all in machines.
You made big little happen, right?
We really helped.
It was a
yeah.
multi-year process to get it right.
Well, I think it was the right thing to do. I think it surprised people by how long it took. And what was missing at the start of the process was a dialogue between the companies producing the IP and the silicon and the kernel community. So you spend a lot of time discussing and aligning and getting to a point where people are trusted. And also, working in the scheduler is a really difficult place to be, and there's some big egos who know what they're doing in there. So ARM and Linaro and our members have got engineers who are right in the middle of those conversations, at plumbers, at wherever they are.
Very big brains, no?
They're bright guys, and the main thing is they're young and they've got a lot of stamina, and they know what they're doing.
And there's fighting teams. There was the IKS and the other and the HMPO. What's it called? And then, but they got everything right. The first generation was
Well,
maybe
there's
a
a lot
little
of
bit,
a lot of
but
code
then
moving
now,
around.
Every 64-bit CPU is big little nearly.
Pretty much everyone.
I mean, the big ones.
So the other, I love toys, as you know, and my I've been wanting an ARM laptop for a long time. I want a computing life where I don't use Intel hardware. It's fine hardware. I'm not not dissing the company, but I like the idea that everything I've got is an ARM device. So as an example, at home, I've just maxed out my router because I've got 33 devices connecting to my Wi-Fi, and it broke the standard one, so I had to get a special router to route it. My current machine that I use every day, and it's mostly meetings and slides and stuff, is it's a Chromebook R13, an Acer Chromebook R13
with the
MediaTek part in it. It's got the big little, it's got the energy-aware scheduler. It gives you a 12-hour battery life. And I can run Android apps. I can run the whole Chrome-based thing. It's got 64 gigs of drive. I can put another drive in. I work on that. So now, I mean, this is the first Connect where I can work completely using ARM technology, and that makes me happy. Plus, as you say, we had a lot of effort and input into that to help make that happen.
And these run Android apps. And,
that's
and
really
Android,
cool. And I'll tell you
Android
something.
is for ARM.
Yeah.
So it doesn't make sense to have an x86 Chromebook.
Not at all.
That's
No,
something I said.
no, not at all. No, I
Because
saw the Samsung announcement, and I like the ARM-based
Chromebook
one.
Plus.
Yeah, I saw that. We had a meeting with some of the Google guys, and they had them.
I'm getting
I don't
mine
want to.
tonight.
I'm not going to buy the. I wouldn't buy the Plus because it's got Intel and whatever. But I was going to say one of the interesting things from a technology point of view is that the way they've done Android apps inside Chrome OS is with containers. And one of the things I've been, in my spare time when I play, I've been looking at all these provisioning and orchestration stuff like Kubernetes and the containers. And it's just amazing what they're doing. And that technology is flowing into gateways, to edge computing, into your laptop. That together with virtualization, you need those technologies to build secure systems that can boot all the way through and to your applications and keep your data safe, but also so that you can upgrade them and you know where the bits came from and they're signed and trusted. So there's a whole, the moment you connect everything to the internet, you've got a whole other raft of problems. But all this technology to provision things is already there in the data center. It's what they do already, right? They deploy thousands of virtual machines. And that technology will revolutionize, some of the other bits of computing.
So there's the
across.
IoT segment, right?
Yeah,
and
we
then
formed
what's going on? And there's Zephyr. And what's going on?
We formed Light, as we call it, Linaro IoT. Well, it's a little bit hokey, but and one of the first things that the big discussion was there's a lot of fragmentation. It's like pre-Linux. There's a lot of fragmentation. Everybody's got their own RTOS. And an RTOS is doing more or less the same thing. It's a threaded environment. It's got some device drivers. You can write some applications. You can probably run JavaScript or Python or Perl or whatever you do.
It's an OS for ARM Cortex-M.
Yeah, so Zephyr came along, and it kind of, the way it's been run, the way it's been governed, its governance model is very open and fair. We looked at it. It was already running on the ARM architecture. But we see Zephyr as an RTOS that can perhaps, hopefully, kind of become the Linux of the embedded space. It's a free and open source operating system. It's got a lot of work happening on it, a lot of technology. But the main thing at the moment is there's a bunch of maintainers. There's a maintainership has grown, right? And so now you've got a social structure within which you can develop the right code. That social structure is probably as important as the code. We've been doing a lot of work there. It's moving really, really fast. It's good stuff. I mean, fair enough, everybody has their own RTOS. They're not going to throw it away. They've got a lot invested in that. But I think as over the next little while, you start to see any device that's going to be connected, then I think you're going to start to see more of that happening.
Because at the opening keynote, there was a demonstration with
George.
96 boards, the small ones, automatically update.
Yes,
and it's very important for security.
And all open source. So what we're trying to do is pull together a reference, something that says build it like this. If you use this bit, and this bit, it will work end to end. So while we have segment groups that are in a particular area, like enterprise, networking, whatever, there's some technologies that run all the way across and need bits from everything. So we have a group of engineers who are pulling together the pieces. So George's demonstration kind of shows the power of what you could do and how it will all start to come together. This is early days for that sort of thing. I don't know about you, I've got plenty of devices at home and they're all little subsystems. I've got the lights and the thermostat. None of them are joined together, but you can see the potential, right? Not in the home and in the factory.
So all these lights are going to update themselves automatically.
And you want to do that safely, and
no hacking and all these issues. There might be some issues about the security cameras getting hacked by Russians I'm joking, but
the problem with security is everybody thinks they can do it, and it takes clever people who really think hard to do it. So I think you're better copying what someone else did, and as a good example. And if you look at some of the various reports about hacking children's teddy bears and whatever, a lot of it is because they took a piece of code, put it in a product, and didn't realize, for instance, that it was also acting as a gateway or creating a hole into your home internet or Ethernet. Sorry. So people just haven't thought about it. It's a difficult topic, and in some of the conversations I've been in with various organisations, there's a lot of people thinking very carefully about how to pull systems together, how to do end-to-end certification and trust and all of that. We have a core technology group that is looking at security. They did the open source trusted execution environment, and that's really works as an example of how to do it. We did a bunch of work around media decode that helps the flow through that. So as I say, this all comes together in a kind of an example of how to do it.
And that's been taken up by all over the world. People are looking at Opti and saying this is the... there's a huge interest, no?
Yes, there is, but they're sort of shy about saying quite what is in there. So we know it's being used in a bunch of systems, as are the commercial versions. But no, it's gratifying to see that it's there. And one of the things that we're doing with Zephyr is putting the Cortex 8M support in. Using a kind of mini container model. So it's about partitioning the secure elements off and the non-secure elements not having access. So there's a bunch of discussion around how Zephyr can really support the Cortex 8M.
And every system out there, proprietary or not, can just take whatever you and use it. For example, it's not proprietary, but let's say Ubuntu Snappy. All the work you're doing is related, right?
Ubuntu Snaps run on ARM. It's similar technology to containers. It's using a lot of the underlying mechanisms. That all runs fine. I mean, we work with a whole bunch of operating system providers, as you know, Red Hats and those guys, and Debian, big community of folks who we really like, who do a whole bunch of stuff. So one of those guys are much more interested in boot architecture standards and making sure things work in a standard way, and a lot of ARM systems haven't been well known for doing that in a common way, but 96 boards is helping pull that together, but still a little bit chaotic.
So would you say after 5 years or a little more, is Linaro overwhelming success? Or could it work faster?
No, I mean,
could you have more people
could we do more?
join?
We
because
could.
Right now there's Google just joined.
Yes.
So,
we're really pleased about
it. There could be much more, right, happening.
Yeah, the Google thing. When we first formed Linaro, we obviously felt that Android was somewhere that we wanted to do something and make a difference, and we just started engineering and being there, and eventually Google has said, well, okay, we'll join, because they recognize what we've been doing, and it's about trust, engineering trust. So it's been really interesting talking to those
Googlers
guys.
have been working with Linaro since the beginning.
Yeah, or quietly on an engineering way.
They're attending Linaro Connects.
Yeah, they particularly when we're on the West Coast, we have a lot of conversations, and now they've joined, and that's great.
And but there's so many ARM companies, a lot of things happening. I mean, there's some consolidation, some crazy consolidation, but all kinds of huge activity and new ARM owner. Many new funds.
But that doesn't
potentially.
The SoftBank acquisition doesn't stop. As far as I can tell, it hasn't changed anything. So there's a part of ARM that owns the architecture, which is mostly who I deal with, and lots of old friends in there. They want that architecture to be in silicon. So they have a model where they publish the specs, they talk to the community. They're here, talking about what they're doing next, the next pieces of architecture and stuff. So there's a relationship between the ARM architectural guys, Mark Hambleton's sort of open source architectural kernel guys, and the rest of us around that. And one of the things I've noticed in the sessions with the committees as well is how much more open people are. 5-6 years ago, people were much more comfortable in a closed room. And don't forget, at that time, ARM v8 architecture was kind of not public. But since then, and with ARM v8 and all of the changes that have happened, everybody's much more comfortable about being open within this environment. I mean, some of the sessions we don't stream because, well, unless you're an ARM licensee or a member, it's kind of difficult. But we're as open as we can be, and more open now than we were. And that's true of ARM, it's true of all the companies.
So just three things I was just thinking about. So you were talking about laptops 4 or 5 years ago. Now there's some Chromebooks and it's great.
Yeah, I really like
but
that.
But maybe we need much more. We need
I
we need stuff that can really where there's no performance discussions anymore compared to Intel.
Okay, so there's two polls about ARM silicon at the moment.
Yeah.
There's the mobile phone, which is a very powerful device. It's a constrained form factor, but everybody's got one. They say, I love my Pixel. It's a really nice piece of engineering. And at the other end, there's the data center hardware, which really is, lots and lots of cores and
huge chip.
Huge chips, heat sinks, the whole, for me, it's like back to alpha days. What I think we're missing are systems which hackers can use, hackers in the right way, use of the word hackers, right? People who write code, can use day to day. So I don't know if you know the NUC sort of format, a little brick with a processor in it, PCI, ePCI, and a graphics card. That's what I would like, and that is going to be not a mobile chip, and maybe it's a cut-down enterprise chip, but one of those is self-hosting. I mean, I use 96 boards, I use the Chromebook and Telnet, SSH into it. And I could build kernels, containers, all that stuff. But I would like a more powerful system.
Yeah, all these guys need to be able to dog food, basically.
Yeah, and they are doing. But we are doing. But
So somebody hopefully has been working on it for a while, and maybe it's going to come out like a Core i5, Core i7 competitor.
I mean, it's a question of is it commercially the right thing to build? But we're having some discussions here. I hope that things come out of it. I think it's the next logical step to enabling the wider development community, because ARM is like a huge private club, right? So the people with access to the hardware tend to work for the companies that are ARM licensees, and what I'd like to see is enabling the wider community so that things get done first on ARM rather than second on ARM, right?
And so the 64-bit was 5 years ago or something like that. There was announced.
Yeah.
And you were very early, and back then you were talking about servers.
Nobody believed us.
Yeah, but so I don't know if there's any stats, how many are there, but I guess it was still the first generation, and we're still waiting for second generation ARM servers,
I
right?
mean,
to really take over the whole market. The 25% by 2020 that ARM is talking about.
Is that right? I don't know what the figures are. I'm not going to predict anything like that. I'll just stick to the engineering. What I know from an engineering perspective in terms of the architecture and the support for it in the open source repositories is there. So, as I say, I've been playing with containers a lot, and container support, all the right bits have been there for a long time now, for AOUT 64.
And Linaro,
so the technology is ready for you to take it where you need to take it. As I say, there's, the Linux kernel is in a great shape for ARM and 64-bit and 32-bit, and it's ready to go where it needs to go, right?
And Linus Torvalds was at the
Well, he was at the last.
Chat with you
I was privileged because that was really great. I enjoyed interviewing Linus, and I enjoyed spending a little bit of time.
And what did he say? He was saying he was happy, right?
Oh, yeah. No, he. So we've gone from being the bad boy of the kernel, right, to actually pretty organised. We set up an ARM SOC group that's really helped put structure and taken a lot of the burdens off guys like Linus to pull together. So there's a whole flow of patches through that, as I say, is aligned with all of the different groups. The guys in the kernel group, finally, the guys in the kernel group in Linaro are brilliant, and they've just worked solidly over the years, continuously making things better. So.
And Greg Korhammer loves Linaro, right?
And we like him to come, and we like him. We're working with him now, obviously. we like him to come and we like him to talk to us. And sometimes he says tough things, things that need to be said. He says them in quite an engaging, humorous way. But go back to the very first question you asked me about us being a number one contributor. That just shows the engineering respect and dialogue. 5 years ago, most of the mainstream kernel guys didn't have a lot of interaction with the ARM community. And when they did, they didn't like it very much. Now they have a lot more, and as I say, the power management stuff, which is all in the scheduler, and there's a lot of respect and understanding, and the way that open source projects work, it's all about trust. You give me your patches, I know you've tested them, I trust what you're saying. I'm not going to pick over all the details. I just care, I trust, and I know you'll do a good job. So that's where we are. It's a good place.
And maybe, I don't know exactly, but one of the bottlenecks that I kind of understand that might be in 96 boards, as an example, is the closed binaries, right? The GPU. But you can convince these guys to open everything up. And the people are talking about AI, all these things. Can everything be open source?
The problem with the GPU space is that it's kind of specialized computing, and the contract between the application and the hardware is kind of at an API level, so OpenGL or whatever. And the graphics guys care about their IP, so it's all the can you see what our patterns mean? But over the last little while, you do see more open source drivers for graphics chips, including in the embedded space. And I think everybody's sort of watching this space. But I'm not...
There's no way you can call somebody and say, come on.
I have conversations all the time, but people have to run their businesses. But we'll see where we go to. I'm not going to make any predictions. You're not going to get me to...
Okay, but I can imagine it's really, really hard for some of these guys. Some of these guys are reverse engineering the
They may be.
That sounds like a crazy hard job.
It is a crazy hard job. Yeah.
It would be easier if just the driver was open source, right?
And a lot of people in open source care because they don't want to run closed code bases. It's a religion, really, kind of. It's certainly a deep philosophy. But we'll see. We'll see where we get to.
And now this 10 nanometer chips coming. That sounds crazy. It's like tiny. It was supposed to not be possible to make it that small.
Yeah, they keep finding ways. Yeah, that stuff is science fiction. That's physics.
But
really.
It gives you more work to do, no?
There's always more work to do. There's always more to do because the other thing that's happened in the 5 years is that I talked about it quite often. Is this move towards open source? For everything, it's a substrate. So what I now talk about is that open source is just the way you develop software. That's it. You develop software by being in open source communities. And there are now more of them covering more scope. So you see things like consortia driving things like OpenStack, which is massive scale deployment. Kubernetes, which came out of Google, all open source. So there's even more open source software in big systems. It's almost dizzy making, just the amount of stuff that's out there.
So people are getting it, right? And and your whole idea of doing the Linaro made sense.
Yeah, it made sense. It's been hard work to get to where we got to. It's always hard work to stay and to keep doing it. But the value is there, it's recognized. And I'm just really grateful that I can be part of this. I think I said 5 years ago that this is the best job in the world, and I still believe that. I have such a lot of fun, and I get to play with computers, and I get to talk to all these clever people and have a beer. And last night we went to see opera. That was brilliant here in Budapest at the Opera House. So I have a great time. It's a brilliant job, and there's always more to do.
And there's so many companies in this industry. ARM is the biggest thing in the world, kind of. But everybody sees a way to differentiate while working together.
Yeah, but the thing about ARM, its licensing model means that you can differentiate. So if you look at traditional areas like enterprise, Actually, it's relatively slow moving. Every year, every 2 years or so, there's a core that's built on a smaller scale. But the architecture is the same. The sub-architecture, the backplane, the data plane, it's the same. But what the ARM companies are bringing to it is diversity of approach. They're flexible enough to try something. The issue that I see is, like, the mobile market moves incredibly fast. New phones, new technologies, very quick cycle. And the enterprise cycle is a very steady state, relatively conservative, slow. And I think when ARM is fully into that area, things are going to have to change to enable it to move faster. Not that you want to mess around with people's data and security, you want to be really, get the engineering really right, but the cycles are too long. They need to shorten. That needs to happen now because we're at this explosion of data. It's beyond an explosion, it's asymptoting to infinity, right?
It's one of the taglines of the SoftBank acquisition. It was accelerating innovation.
Well, yeah, I mean...
So hopefully there'll be more R&D funds, and I guess it's not just a question of hardware, it's a question of software. It
is entirely software, yeah. I mean, software is something like 3 times the cost of hardware and all that, but what the SoftBank acquisition has done for them is take them off the stock market where they had to go, results every quarter. So, as I say, I'm not part of ARM, so I can only speculate from the outside, but from what I'm seeing is that the architecture's in good hands.
But hopefully if there's need for more R&D, there
There's
might
always
be the
need
funds
for
for
more,
that.
yeah.
There might be support
and
for
they're
that.
clever people. Things are happening. I'm completely confident that some great stuff's going to come out from them and from all of the partners.
And when there's 1 trillion ARM chips all over the world, there's going to be Linaro and everything, all of those.
I hope so. I hope that long after I'm gone, that this thing called Linaro is there and is part of how things happen in a good engineering way. The original argument for Linaro was, hey guys, let's not all do the same thing slightly differently. Let's do the common bits together, the boring bits together, and in the open. And that works. And that works not just when you're creating new architecture, it works when you're pulling together big systems. It works in a steady state, right?
All right, and hopefully the singularity is going to be a positive thing.
Yeah, I hope it arrives before there's interesting stuff. The great thing, as I say, I've got the best job in the world. I'm always learning. I'm always talking to really interesting people, and long may it continue. So I hope I'm around in 5 years' time when you interview me again. But as always, lovely to talk to you, Charbex.
Cool.